But we want to show you guys real quick, and I'm going to tell you this next section is a little rough because I didn't finish my job today. It's not Joseph's fault.
It's okay. It's my fault.
Yeah, I didn't.
I did some more stuff on it before this thing started, so it's a little bit better. But
all right. Anyway, I want to tell you guys this is very basic. This is non-scientific and very basic. But there's three basic ways that we can get heat off of something. We can use conduction or diffusion, which is through direct contact. We can also use convection, which is through the movement of air or liquid or some kind of other medium. And then we can also do it by radiation, which is the removal through the emission of electromagnetic radiation. So those are basically the three ways that we got to move heat. And, you know, the biggest thing, let me turn this off for just a second. The biggest thing that people misunderstand about thermodynamics is they don't think of heat as its own entity. And it is. It's its own thing. It's energy. It's its own type of energy. Cold is nothing. Cold is simply the absence of heat. If you cannot think of cold as a value of heat, okay? Cold simply means, man, there's not enough heat in here, okay? But heat is the actual quantifiable value that we're looking at, not cold, okay? So let's not talk about cold. What we're talking about is the amount of heat. Even on the moon, there's heat. You could say, well, the moon is colder than hell. It's minus 200 degrees in the shade. And what? Yeah, it is. But you don't measure it in cold. You measure it in heat. Even in absolute space, there will still be passing energy coming by. And there will be something. So basically, heat is the amount of energy, the amount of heat energy that's in an object, or that's on an object, or that's being contained within an object. So that's how you have to look at heat. Your air conditioner in your home, okay, does not make cold air. Doesn't do it. Never did. Not from day one. What it does do is it takes the air that's within your home and it takes the thermal energy out of that air and deposits it just outside the wall. That's what it does. I want you to think about it. Your air is putting out cold air. You walk outside. What's the thing outside doing? It's putting out hot air.
Hot air.
Right. Yeah. It's not hot because it's working. It's hot because that heat energy was just removed out of the air in your home and placed in the air outside your home. That's why when you see the idiot with the air conditioner sitting in the middle of the kitchen floor on a hot day, the little the window air conditioner, I just laugh. I'm like, yeah, it's cool, right in front of that thing. But
hot on the other side.
You're actually, yeah, it's actually making more heat because the compressor and the fan motor are actually making heat also. So you're actually working in the wrong direction. An air conditioner doesn't make cold. It simply moves, and it doesn't get rid of heat. All it can do is move thermal energy from one location to another. So that being said, using the same principles that your air condition uses right now, I introduce my co-host, Joseph. He's going to explain to you how to use this same technology to cool your radio, your computer, and, well, maybe even your tool. I don't know. Here you go, Joseph.
Hold on one second. Let me do this screen share thing.
See, I came to you too fast. I knew it.
I didn't know what was going on. I wasn't sure what to do.
If we were in the business, you'd be going like this right now. Stretch, stretch, stretch.
Deer in headlights.
Hold on, where's the button?
I could do this too, but you're certainly welcome to. It's probably easier that way.
Can y'all see it?
Yeah.
Can y'all see where it says? Y'all can see it?
Water cooling your equipment.
Well, Ian pretty much already went through that. We can go back a little bit.
Yeah, you go to the next one there, yeah.
Why does the left and right keys not do anything? Can y'all not see it? Hold on. What do y'all see right now?
When we're seeing when an SDR
operates above 1 gigahertz.
Ah, okay. Yeah, so when these things are on lower frequency VHF, UHF ham bands and stuff, they generate a little bit of heat, but not very much. And just the air conditioning in your house is enough to keep it cool. But the higher the frequency you go, the quicker this thing generates heat. And so when you go above 1 gigahertz, it starts to really get hot, and it gets hot quick. Like if you run that for even just a few minutes, it'll get so hot that it's painful to touch. So, and when that gets hot, it loses sensitivity. So I think there's a little bit more thermal noise in there. So the noise floor actually rises and the sensitivity falls. So if this thing gets really hot, it'll pretty quickly become just completely useless. So to solve that problem, I've done this. I got a Peltier, which is a little device that you give it power, and it sucks the heat from one side and puts it on the other, leaving cold behind, like Ian was saying. Y'all see my cursor? I just want to make sure I can see my cursor on here, so I can point at stuff. Anyway,
it's not very big, but we can see it.
Okay, so the little white line here, that's the little Peltier, and when you give this thing 12 volts, it gets cold instantly, like ice cube cold on one side and like fiery hot on the other, like instantaneously. So what I've done is I've used thermal glue, and I've attached one Newelec RTL SDR dongle to one side of it, as well as some little heat sinks as well. I guess you can call those cold sinks now. And then on the other side of the Peltier, I've got this aluminum water block. So as you can see here in the left picture, it's got these 2 little holes on it, and you can stick a hose on there and actually pass water through it, and the water or whatever else you're using will carry the heat with it. I used water in this because that's all I had, but you can also use oil of various different kinds, and they also make special thermal conductive fluid. Gaming computers, similar to the one I have, sometimes people decide to put in a water cooling system, and so they will have a special CPU cooler and a little reservoir and a pump and a radiator, and they put special water cooling formula in there, and it carries heat a little bit better, as well as sometimes like different colors and stuff to look cool. But I just use water, and it seems to work fine. So the water goes to these 2 hoses here. One of the hoses goes to the outflow on this here water pump, and this is just like a fish tank water pump. It's a 12-volt water pump. It costs like $8 on Amazon, and it runs on 12 volts. All the equipment in here runs off 12 volts, except for the dongle, but that's just powered over USB. So the hose comes out of the little aluminum water block and goes into the pump, and then it comes out of the pump into this little blue rectangle, which is actually a CPU cooler water block that I got from Amazon. One side of it is made out of copper, and it actually passes water through. You can see the 2 hoses on here. So you put a bunch of water in there, and it comes out the other side, and it either takes heat with it, which it would for a CPU, but I'm actually using it in reverse, so it's actually leaching some of that heat out. And it's taking that heat out, and it's putting it through the case of this Pelican. I have a Pelican case. It's a pretty small one, but I cut a hole in it with a Dremel tool, and this little water block actually sticks through onto this giant heat sink that I found, and it's attached to the aluminum block with more thermal glue stuff. And so I've got it stuck on there, and I've got a couple extra heat sinks on here. But this thing is really big, and you need a big heat sink like this, especially for the application I'm using, which is going to be putting this outside where it's already hot. You need a big old heat sink. And this one actually works perfectly because it's the right size, and you can put a fan on either side of it. So yeah, you can see it goes in here through the case, comes out. This is just sitting on the lid of the box, and it's also glued down so it doesn't come off. And so that's that part of it. It actually has a watertight seal with hot glue, and that's how you get heat from inside this box to the outside. So here on the left is an overview picture of the whole thing. Well, most of it at least. Dongles down here, power cord. So the water goes up, passes through the blue block, which transfers the heat to that giant heat sink. And then from there, it goes to the, actually, I think I'm pointing it out in reverse. I have a picture here. Here we go. So right here, in the center here, we have this bottle that's on the side, and that's my reservoir. You kind of need a reservoir for this to work because the pump has to be primed. It won't really create enough vacuum to suck water through it without already having water in it. So you kind of have to have a little bit of a reservoir on there of water with both of the hoses submerged for this to work. So otherwise, there'll just be air in there and it'll just sit there spinning with air. So what I did is I put this little medicine bottle on here and fill it with water, and then you can tilt it around and get all the bubbles out. So from the bottle, it goes directly into the pump. The pump pushes it out into the aluminum heatsink block, and then it goes in there. Then it comes from the heatsink block over into the aluminum block on the dongle, and out of the aluminum block into the reservoir. So it kind of works in reverse. It's maybe not the most efficient. Basically, the hot water is going into the bottle, and then from the bottle to the heatsink. But that's kind of good because it does give you a bit of a buffer, and it actually cools a little bit more when it's in the reservoir. Inside the bottle here, you can see the two holes where the hoses come in with the water. So yeah, that's pretty much the whole thing. Yeah, here we go. So that's the overview of it. And it's right now, it's not a permanent, it's just not finished. I'm using zip ties to hold the hoses on, and those leak out water. I need to get some hose clamps and maybe some different piping. But it does work. I ran it, I did a test with it in my bathroom in the sink, and I let it run for about an hour. And oh man, I don't have the picture in here. I completely forgot to put the picture in here. But basically, it reached about 97 degrees. I put a little thermometer in the reservoir. It reached about 97 degrees, and it sat there at 97 degrees indefinitely. It had a fan. I put these two little computer fans here on the heatsink, and just sitting there in the not really good airflow position, it actually reached a stable temperature with the dongle on, with the Peltier on, generating a whole bunch of heat out the side. And once I did that, there's actually a lot of condensation forming on the dongle, which does have me worried that it may cause me issues later. But for now, I'm not going to worry about that. So yeah, that cools it. And you have to cool these things, especially if you're putting them outside in the heat, because they don't like the Florida heat. That's what the next slide is for here. This is what I'm trying to pick up. This is the GOES 16 satellite, and it actually has this like sort of spread spectrum style of transmission. It's not just like one line. All those little short lines you see there, those are data transmissions from the satellite. And if you don't cool this thing, those will fade away into nothing, and the noise floor will rise up a good bit. So this is with the dongle pretty cooled down, and you can see the signal is pretty clearly visible there. And it's picked up pretty well by the GOES Tool software. So that's the goal with all this, is to make this work outside in a nice little storm-proof case. I know it's very impractical. I mean, a water cooling system is kind of like ridiculous for this sort of thing. But I don't know. I just wanted to mess around and have fun and build something cool. So that's mostly what this is about. But water cooling your electronics, and this brings me to like the other stuff, not just this particular application. You could do something similar for a ham radio. A lot of these ham radios now, especially the 2-meter radios and whatnot, they generate a lot of heat. Most of them have a fan on them now, but they still get quite hot. And if you're having issues with heat, I don't know, maybe something like this might work. You could have one of these aluminum blocks on there, just on the outside of the case, and you could attach that with some thermal glue, or even just like thermal sticky pads, so it's not like a permanent thing. And that'll probably help you out, transfer a lot of your heat away. It is just a bit, it's a bit complicated just to cool something. There's other easier ways. Just use a fan and a heat sink, but this is just kind of a cool little idea here. So yeah, other things I want to do are water cool a computer, and maybe I'll make like a water cooled UV5R or something at some point. That would be pretty hilarious. But yeah, so it's not super practical. But it's cool, and it's water cooling. So this is the goal, and it works pretty well. It actually does keep the dongle pretty cold, almost too cold. I'm a little bit worried. Anyway, that's
As long as it cuts the noise.
Yeah, it definitely cuts the noise. See, here's the thing: when the dongle is at room temperature, and I put this thing outside and connect it up, I get a signal strength of about like 300, which is pretty good. But when I cool it down below room temperature, it actually gets even better. The signal goes to about like 230, which is really, really good. So cooling it actually helps it even more past like normal room temperature. So yeah, if I do that, then I should have a nice, reliable, strong signal. I won't have to worry about hot days. It'll have plenty of headroom to get warm. And yeah, so it's just kind of a cool little thing I did. But that's pretty much it for my presentation.
All right. Well, there you go. That's awesome. I got to tell you, I use a window unit. You can see it right there. That I mounted in the wall. I did something a little crazy. They said I needed a ham shack, so I went and bought one. I actually had this sat here on my property the same week that I got my amateur radio license. It's a 10 by 14 shack. It's basically a Miami-Dade hurricane rated shed that I had put here and anchored down. Yeah, it's the best secondary building you're going to get. I mean, they really don't make these to withstand the big one. But I've shorted up the best I can. I've got it tied down. I paid a little extra, have some more tie downs on it. And I also got, I've finished the inside out too, which helps to strengthen the entire structure. So I finished the whole thing out, painted it, put my shelves, built everything all in here. And so this has all been, a labor of love here. It's not the spare bedroom, if you will. It's actually a shack out in my backyard where I do all this stuff. And